Hi. So what we're going to look at now is how do you name alkanes? So we have no functional groups in here. It's all hydrocarbons. And what we want to do is a couple things. The first thing is you want to find the longest continuous carbon chain. So if we go through here, I think the longest chain is right through the middle. And then at this point, if we keep going straight across, we can go 1, 2, 3, 4, 5, 6. But if we go up, we can go 1, 2, 3, 4, 5, 6, 7. And so we can actually get a longer chain going up and over. Alright, so it doesn't have to be straight across, it's just the longest continuous carbon chain. Alright, then the next thing we want to do is number from the side that gets us to the first substituent. And a substituent is anything that's not part of our parent chain. So everything that I've put a red line through is our parent chain. Anything else is a substituent. So this one, and this group here. Alright, so we're going to number from the side that gets us to the substituent the fastest. And so that in this case it's the left. And now we'll just number across. We're 3, 4, 5, 6, 7. Alright, so 7 carbons is heptane. And that's something you just want to commit to memory. I would at least memorize the first 10. Alright, now that we have that, this is going to be our parent chain. Now we have to name all the substituents. So if we look back, 1 carbon is methane. And when it's a substituent, we change the ending to methyl. Alright, so we're going to drop the ane and replace it with YL. And this is true for all of them. So it had been ethane, it becomes ethyl. Right? So now, on carbon 2, we have 2 methyl groups, right? A carbon here and a carbon here. And we have to give each of them its own number. So what we're going to have is 2-methyl. Right? And since there's 2 of them, what we can do is use the prefix di. And what I meant by each of them has to have its numbers, even though they're on the same carbon, it's got to be 2,2-dimethyl, right? Because we've got to be overly explicitly clear where each of those methyl groups are. And so since they're both on the same carbon, we have to tell everyone we have 2 methyl groups, right? We say that with the di, and exactly where they are, and they're both located on carbon 2. All right, now in the next one, we have an ethyl group, right? Because we have 2 carbons. So it goes from ethane to ethyl. Right? And now the same, it's on carbon 4 is where it's branched off of. So it'll be 4-ethyl. Right, now the last thing is, we know that the parent chain goes last. Right, so this goes at the end of the word. Now the substituents we alphabetize. And what you have to be careful about is we alphabetize them by the root word. So we're going to compare methyl to ethyl. We don't use the di. Alright, so we only want to compare the M and the E. And it's really easy to get tricked because if you look at this, D should come before E, but we don't use di, tri, those types of prefixes for the number. So now if we put this all together, it's going to be 4-ethyl, two. Remember, we have to have a number for each substituent. Dimethyl. And now we just use our parent chain, which is heptane, because that came from the number of carbons. And we've successfully named the compound. Alright, so just to kind of review, make sure you find the longest continuous carbon chain. Right, it's easy to want to just go straight across the middle, but we can zigzag, twist, and churn as long as we find the longest carbon chain. And then we pick what side to number from based on whichever one gets us to the substituents the fastest. Alright, let's try another one. Same idea here. I think in this one, the longest carbon chain is right through the middle. Alright, so let me highlight that in red again. Alright, so it goes right through the middle. Now this one is the question, do we want a number from the left or from the right? If we start on the left, we can get to our first substituent in the 2 position. So it'd be 1, 2. If we start on the right, we can get to our first substituent again in the 2 position, right? Because we would go 1, 2. So since they're both tied, now we see which one will get us to the second substituent the fastest, and it's here on the right because then our second substituent is also in the 2 position. All right, so that tells us that we're going to number from the right. All right, so our parent chain is 6, so 6 carbons is hexane, so that's going to be our parent chain. Now we have our substituents. It's 3 methyl groups, so the prefix for 3 is tri, so it'll be trimethyl. Remember, the ethyl portion tells us that it's a substituent. And then we have to have a number for every one of these, right? So if there's 3 of them, we need 3 numbers. Right? So in this case, it'll be 2, 2, 5, right? And the 5 is here, and then the 2 2s come here and here. Okay? So it's 2, 2, 5 trimethyl. And then now we just put our parent chain, which is the hexane, and we're done. Right, so this one looked a little more convoluted, but it was really just deciding which side of the chain to start numbering from. Let's look at another one. I think in this one, if we kind of look at it, we can go through the middle here and get 1, 2, 3, 4, 5, 6, 7 carbons. So I'm just going to put that on the side. Let's try another one. What if we go through here, 1, 2, 3, 4, 5, 6, 7, 8? So if we can get 8 carbons, that's the track we want. So you got to be really careful that you truly find the longest carbon chain. So let's go right through here. And now, I think what we want to do is start numbering on the right because we can get something in the 2 position. If we started down here, it'd go 1, 2, 3, 4. So this is the better place to start. So let's do this where we put 1, 2, 3, 4, 5, 6, 7, 8. And then if you remember, 8 carbons is octane. So that's going to be our parent chain. Now we've got to name all the substituents. So in the 2 position, we have 2-methyl. We have another methyl in the 3 position, so it'll be 3-methyl. And then we also have this ethyl portion out here, and so that'll be 5-ethyl. And now we just put them together. Remember, we can combine these two to make 2,3-dimethyl. So we have the 5-ethyl and the dimethyl. Remember, we're only alphabetizing by the M and the E. So the E comes first, so it'll be 5-ethyl, 2,3-dimethyl. And then we use our parent chain, which was octane, at the end. And that tells us the number of carbons in our molecule. And so our total IUPAC name for this one is 5-ethyl, 2,3-dimethyl octane.